Friends, good morning. Today I'm going to talk to you about a biometry validation tool that I have developed, which I'm sure is going to interest you because this tool helps you to validate the biometry data that you generate for premium IL patients for cataract surgery. I realized the importance of developing this tool as I have done a series of biometric programs over a period of time. And I thought of developing a simple tool which would help you to validate the data. So let me show you the tool. So what you see on the yellow here is the surgery data, and if the surgery has been already done, the surgery date, the post-operative manifest refraction. Here you can put the post-operative manifest refraction, and the refraction wake, that is how far after the surgery you are taking the manifest refraction. So if it is 2 weeks, then it is going to give you a red flag because that may not be a stable refraction. So if it is 4 here, it will only accept values without a check mark, a red check mark from 4 weeks onwards. You can put in the nature of complaints, the eye operated, and the IL power and the toric model if it is applicable. But what I wanted to show you, the most important part, and where this tool actually helps you to validate your biometry data, whether you want to do it post-operatively. If there has been a surprise, you can go back to your biometry data to validate the tool, or you can do it not waiting for a post-operative surprise to happen. You can do it even before when you are doing the biometric calculation pre-operatively. You can put in the values over here that you get from your biometry machines to validate the data. So the green part is the entire green part here is your preoperative biometric values that you have to put in here. So what you put over here is the eggshell length. So I put over here 23.5. That's fine because it's an average eggshell length. But what happens if I put says very low eggshell length, a small eggshell length, it gives me a red flag over here. It shows that this may be beyond the average eye, so it gives me a check mark over here. The other thing I wanted to show you is the importance of the Wang and Koch optimization for very high eggshell length. So if you have put a very high eggshell length, say for example 27.9, then again it gives you a warning that this eggshell length is too high and beyond the average values. I go back, I say okay, so I continue with this eggshell length, and immediately it gives me the Wang and Koch optimized eggshell length for SRKT formula. As of now, I've included only for the SRKT formula. For any eggshell length beyond 27 millimeters, I have included the Wang and Koch optimized eggshell length values against the eggshell length that you put from your biometry machine. So this cell actually automatically optimizes. Let's go to the phakic ACD. So the ACD, anterior chamber depth, I put in an average value over here, 3.0. So it doesn't give me a warning sign. It gives me a green sign. That means that this is an average anterior chamber depth. What if I put 2.1? It then immediately gives me a caution over here that this is beyond the average values. What it also gives me is the predicted post-operative pseudophakic ACD. So the predicted post-operative pseudophakic ACD is automatically calculated when you put in the phakic ACD, and this may help you in your effective lens position, I mean where the lens might be sitting, how far it is sitting from the cornea, and this may help you to determine if there has been a refractive surprise. You can go back to this and see how far this actually, the predicted post-operative pseudophakic ACD tallies with your real pseudophakic ACD when you measure after the lens implantation. So if you have measured the pseudophakic ACD to know the effective lens position of the patient, then you can, and if it is more than a certain value, you know that this is actually because of the effective lens position shifting, because it is far beyond the predicted pseudophakic ACD. So if you put again 3.2 and put a value over here, it goes green over here, phakic ACD, because that's an average value of a phakic ACD. And immediately it calculates the predicted pseudophakic ACD, and you can tally this, you can compare this with your real pseudophakic ACD after the surgery. Axial length of the other eye is also important. So I have an axial length of 27.9. Let me change this axial length and make it an average value over here, 23.5, and the 23.5 axial length is actually so the two eye axial length difference, I will just show you in a moment. So the other eye axial length is 23.3, right? So it gives me the two eye axial length difference is 0.3. So it gives a red flag here because that's beyond the average. So the two eye axial length difference, if this is the right eye, then the right eye axial length difference and the left eye axial length should be within 0.3 millimeters. So it gives you a red flag over here. So immediately the biometrician knows that there's something wrong and he can remeasure here. What if I put the other eye as 23.01? So the two eye axial length difference is now only 0.01. And immediately the check mark goes away, so all good to go. You can also put the standard deviation of the axial length over here, and it will tell you whether you are within the bounds, within the limits, or is it beyond the average limit. So that's an important indication that it is going to give. What if I put it 0.9? And then again, it is going to tell me that the standard deviation of the axial length is just too high, and the red mark is going to come. Let's move on to the keratometry readings and the steep K here. Say, let's put the steep K as 45 and the flat K as 44, and it gives me the green, indications, meaning that this is well within the average keratometry reading. What if I put the flat K as 40? It immediately gives me a warning here that this may not be within the average readings, and so it advises me to go back and remeasure again. So it gives a red flag over here, right? So what's the difference between the two? The difference is the cylinder is the 5, which is automatically calculated, and I put the axis at 90 here, right? I have an option to check this eye's keratometry readings with the manifest refraction here in this column. Also, I have an option to check the keratometry reading of this eye with the other eye, which is in this column. So let me check with the manifest refraction. Remember, the keratometry reading says that the cylinder in this eye is 5 diopters. So if I put something around, say the manifest refraction is +2, then it is again going to give me a red flag over here because the manifest refraction is not tallying with the cylinder values. So it gives me a red mark over here. What about the axis? If the axis is within a certain value, then it's not going to give a red flag. But the steep axis from the K readings and the manifest refraction are here tallying well. But if it doesn't, then it will give me again a red flag over here. You can also put the standard deviation of the axis and the standard deviation of the keratometry readings. These are important. Recent studies have shown, research have shown that like we take care of the standard deviation of the axial length, we should also note the standard deviation of the keratometry readings or the axis. And if this, you don't need to remember the standard deviations. The calculator takes care of that. So if you put a standard deviation within out of bounds, so it's basically going to give you a caution mark, and it is so it says that basically that the standard deviation of the axis is beyond what is the acceptable limit, and that could be because of irregular corneas, that could be because of the dry eyes. So wherever you are going against your average values or the biometry rules, it is going to give you a check mark over here, and you get an indication whether this patient is suited for a premium lens or not. And so I was telling you that you can check the K readings either with the manifest refraction, or you can check it with the other eye K readings also, or both. So let's put a value for the other eye steep K. So this other eye steep K is say 48. So this is beyond average cutoff values. So that is why it gives you a red flag. What if I put an average value over here, which is 46 over here, and the flat K I put again as 42. So the K reading in this eye, the cylinder is for 4 diopters. In the other eye, the cylinder is 5 diopters. So in the two eyes, there's a difference of 1 diopter of cylinder, and that is why it is giving you a red flag over here. So this column notes what is the K difference between the two eyes. If the K difference is less, between the two eyes, then it is going to not provide a red flag. So for example, if I put 46 over here, say for example, I change this to 46, so there's no cylinder over here in this eye, and I change this to 44.5, and so you have a cylinder in this eye of 0.5 diopters. In the other eye, you don't have any cylinder. The difference of cylinder between the two eyes is 0.5, so it doesn't give you a caution. So it is well within the acceptable limits, So likewise, it can help you if your biometrician puts this data in this tool. It helps him and you also to understand how many red flags or how many green flags are there, and accordingly you can decide whether you want to go for a premium lens. The other notable thing that I wanted to draw your attention is that that in optical biometry we get something as angle kappas and angle alphas. It doesn't really say angle kappa or angle alpha. It actually points out to the iris barycenters. Several of the optical biometers point out to the iris barycenter and the pupil barycenter, which are basically if you look into the iris barycenter, it is the deviation of the optical axis from the corneal vertex. I say corneal vertex because you cannot measure the visual axis, and it is thought that the visual axis will be closer to the corneal vertex. So in the X and Y coordinates, you get this data from the optical biometry, and I put this as 0.2. I put this as 0.3. This is not a simple addition. There's a formula that goes in. So the 2i, how far is the optical axis deviating or far away from the corneal vortex? It is well within the limits here in this patient. But what if I put this as 0.9 and something as, what it shows is a red flag, means that this patient's optical axis is well outside the corneal, the visual axis, away from the visual axis. It's the same thing over here is the chord mu. In this place, why we say chord mu is, or the chord length, is because it doesn't give the angle kappa, it's giving the distance. So you can put in over here the values from your optical biometry from the pupil barycenter. So you can put the 0.5 over here and 0.2 over here. Both together, actually, it shows that the pupil center, the pupillary axis is removed away. It is far away from the corneal vertex. So hence there's a red flag over here. It helps you to choose multifocal patients because this is again connected to dysphotopsia. So after surgery, if you find the patient having halos and glares, you can check these values over here, or I would advise even before the surgery, when you're planning a multifocal patients, you can put these values from your optical biometry and check whether they are beyond the average cutoff values, so that you can avoid the nature of complaints from the patient after the surgery. So that was, in short, my first version of validating the biometric tool. I plan to make it more robust in terms of post-operative, adding more functions on the post-operative details. But as of now, I hope this biometric tool validating the biometry data will help you. Thank you very much for your active listening. For more informations, for more articles on biometry, topography, and monofocal IOLs or multifocal IOLs or toric IOLs, you can go to my blog, quickguide.org. I repeat, quickguide.org, where you will find a host of informations. You can also keep following my YouTube channel and do not forget to subscribe. Thank you very much for your patient listening.